So today we'll be looking at the constant velocity lab. My name is Xing'an and I am in lab section M02. So the objectives of this lab is that we're going to observe an object in constant speed and constant motion, so no changing directions, and we're going to use a software called Tracker to analyze the position and the corresponding time of the object. Afterwards, we are going to create a computational model, a predicted model based off of Newton's second law and the momentum principle. So here are the formulas that we're going to use to find our final position and our final velocity. So what I did in this lab is that I simply dropped an object from a height. If I pull up Tracker, you can watch a video of it right here. That's all I did for the object. I just dropped it from a specified height. And so if I click at the graph right here, as soon as it right here, you can see the data right here. Theoretically, it should just be a constant line. I think that the bumps right here are due to me kind of not putting the center of mass in the correct place on Tracker. But other than that, it should just be a constant line below the axes. And as you can see right here, here is the time and the corresponding position in a table right here. So then afterwards, I used a software called vidle. And what I did is that I ran it, and here you go. You can see the object is falling, and that's what it should do because I did set it in the y axis. And here are the corresponding data. So here is the time in seconds and the corresponding position. So afterwards, I compiled them together into an Excel spreadsheet. So here the blue line represents the experimental line from a Tracker, and the red line represents the predicted model from vidle. And as you can see, there is a considerable gap between the two. I think that the big difference between the two is mostly because the center of mass wasn't shifted or oriented correctly on Tracker. But other than that, you can still see a really solid constant line below the axis to represent the position versus the time in both models. And so now we're going to be moving on to some questions. So what if I oriented the axis in a completely different way? So instead of putting it on the y-axis, I put it on the x-axis. And my hypothesis before doing any testing was that it wouldn't really change. The data will still be the same, except it would be oriented in the x direction as opposed to the y direction. So afterwards, I did use Tracker and run a little test. So you can see well, you can't really see here, but I did orient the axis differently so that this vertical line right here is the x-axis and the horizontal line is the y-axis. So it's the same video, but afterwards, when I click here, this is the same, pretty much the same line. It's still a constant line below the axis right here, except now instead of y, it's time versus x, and the coordinates are relatively similar, except that it's in the x dimension instead of the y dimension. And if I used vidle to do this, instead of the ball falling down, it would probably go to the right because it would be traveling in the x dimension instead of the y dimension. So moving on to our next question, what does it mean? My observations can be predicted well by the computational model when I set the net force equal to 0. As you can see in vidle, I did set the force right here equal to 0. But how do I account for that? So there are so many forces acting on the object. There's the gravitational force, and then there are also internal forces. But right now, I'm going to discount all of the internal forces because I am counting the force of the interactions on the system, which is our object right here. So the only forces that are in this model are the gravitational force with the negative 9.8 meters per second squared acceleration, and once the object hits the ground, the normal force balancing it up and holding it up. So that's all I have for my lab. Thank you so much.